Hi there, my name is Miss Townsend and I love math. This video is a quick video for data management students who are preparing for the exam. It's question number 25, hold on. 25, which may be listed as 26 if you don't have the updated number set. And it says that you have 4 friends who are all going to roll a dice, and that's a standard 6-sided dice. And we want to find the probability that at least 2 of them roll the same number. So, we can start by talking about the sample space. We know that we're about to do 4 different little tasks, each of which is rolling a 6-sided dice. So here's the 4 tasks, and each of those dice is independent. We know that there are 6 outcomes for the first friend, 6 outcomes for the next friend, 6 outcomes for the third friend, and 6 for the last. So in total, there are a total of 1,296 possible outcomes of the experiment roll 4 dice, or 4 different people roll a dice. Now let's talk about the sample space. What we want is to count an event space in which at least 2 roll the same number. Now, the best way to approach this is to think about what the opposite of that is. So I'm looking for at least 2 of them to roll the same number. So 2 to be the same, or 3 to be the same, or all of them to be the same. So the opposite of that is that no one gets the same number. So everyone has a different number. So I'm going to actually do that. So I'm going to actually calculate the opposite of the event stated. So I'm going to calculate no one gets the same number. So the opposite of at least 2 have the same number is that no one gets the same number. Because, I mean, there's just no such thing as one of them gets the same number. You don't have one thing being the same. You either have 2 the same, 3 the same, 4 the same, or none of them are the same. Now, another way that might help to think about that is that they're all different. So let's count, because it's going to be a lot easier than trying to count 2 the same, 3 the same, 4 the same. Let's count the event where every person has to roll a unique number. So that's an easy task. So if I want each person, when they roll the dice, we know they all have 6 options, but I want to count all the ways that they roll a completely different number from anyone else. So let's start with the first person. No one's rolled yet, so that person can get any number they want on the roll. Now, when the next person goes to roll, I don't want them to get the same number as the first person. So that means that this person, there's only 5 outcomes we want, because I don't want them to get whatever this person had. So the third person, I don't want them to match this number or this number, which means there's only 4 things that can be considered to be good for them to roll. And then the last person, they can't match this, or this number, so there's only 3 possibilities left on that dice. So if I do this math, 6 times 5 times 4 times 3, beep, pop, boop, calculator, boop, I get 360. I hope that's right. 20 times 18. That sounds right. So of the 1,296 possible outcomes, 360 of them have all unique items. And that means the opposite, if I do 1296 minus 360, I'll be able to tell you how many of those outcomes have at least 2 of them being the same. So 936. So 936 of all possible outcomes are not unique outcomes, meaning at least someone matched a number. And therefore the probability that we're looking for is 936 out of 1296, which is 72%.